Hi dear students, in this video I am going to discuss some fundamental topics of chemistry. As I have told you already in the previous video that we are using ChatGPT, that is the most powerful artificial intelligence tool, large language model, and by using this and we are going to learn chemistry and from basics to advanced level. So here the prompt I have given to ChatGPT is what are the fundamental particles of an atom and how they are arranged in an atom. Give the values of their masses and charges in a tabular format. This is the prompt I have given to ChatGPT, and here is the response of ChatGPT. So here is a table detailing fundamental particles of an atom, their arrangement, charges and masses. See, first column, particles, proton, neutron and electron. So these are the three fundamental particles we know, and their symbols are P for proton, small p for proton, small n for neutron and small e for electron. And their charges, charge of proton is plus 1.602 into 10 raised to minus 19 coulombs, whereas charge of electron is minus 1.602 into 10 raised to minus 19. So there is a only difference of this sign plus and minus. Magnitude of the charge is same for both proton and electron. See here, there is no difference other than the sign symbol. So plus and minus 1.602 into 10 raised to minus 19. It is important to remember the charge of electron, because in some numericals and some problems we will use this value many times in chemistry. And where it comes to neutron, neutron has no charge, zero charge, it is a neutral particle. And next comes to mass. So in case of mass of proton is 1.673 into 10 raised to minus 27, whereas mass of neutron is 1.675 into 10 raised to minus 27. If you compare, if you observe these two masses, both are approximately same, only difference is 1.673, here 1.675. So that means negligible difference, as both are 10 raised to 27 minus 27. Next, when it comes to mass of electron, it is 9.109 into 10 raised to minus 31, 10 raised to minus 31 is very less in comparison with the mass of proton and neutron, and their relative masses are given in this next column. Relative masses, mass of proton is considered as 1 unit, whereas mass of neutron also 1 unit, both because both are almost same. And next, mass of electron is 0.00054858, that means it is approximately 0, is a very less value, very less value. So in comparison with the mass of proton and the neutron. And come to their location, where they are actually present in an atom. So here proton is present the center of the atom, that is called nucleus, and neutron also present at the center. Both proton and neutron are present at the center of the atom, and whereas electron is present outside the nucleus, and actually electrons revolve around the nucleus. So like see here, I will show you some diagrammatic representation of this. One second. Suppose if you take let it be an atom, and this is the nucleus, center point. This nucleus consists of two fundamental particles, those are protons and neutron, and electron revolves around the nucleus like this. Electron revolves around the nucleus, and proton have positive charge, neutron have no charge, 0, and electron has negative charge. So that's all, very simple. Okay, next we'll continue our discussion. Proton, positively charged particle found in a nucleus of an atom. It has a relative mass of 1 and a charge is of approximately 1.602 into 10 raised to minus 19 coulombs, whereas neutron, electrically neutral, found in nucleus of an atom, it has a relative mass of 1 and a charge of 0 coulombs, because it is a neutral particle, whereas electron, negatively charged particle found in electron cloud surrounding the nucleus. It has a relative mass approximately 0.00054858, and you no need to remember this value, okay, as a charge approximately minus 1.602 into 10 raised to minus 19 coulombs. The arrangement of these particles in an atom is as follows. Protons and neutrons are located in at the nucleus, which is center core of the atom, whereas electrons orbit the nucleus, means surround the nucleus in an energy level or shell and forming an electron cloud. The specific arrangement of electrons in these shells is governed by atom's atomic number and electron configuration, right. So this is about 3 fundamental particles. Next we'll come to the next prompt I have given is explain atomic number and mass number with examples and how an element is represented. See here, the ChatGPT is given its response in a very nice manner. Atomic number of an element represents the number of protons found in the nucleus of an atom of that element. So very simple. Most of the students get confused and even don't know what is atomic number. When I ask any student of mine what is atomic number, generally they say, sir, atomic number is hydrogen 1, helium 2. What does it mean? Hydrogen 1, helium 2, what does it mean? It means that the number of protons present inside the nucleus, that is atomic number. See, why atomic number of hydrogen is 1? If you consider this is a hydrogen atom, this is the nucleus of hydrogen atom, it consists of only 1 proton inside its nucleus and 1 electron around its nucleus, and 1 electron revolves around the nucleus, that is all. And one more interested point is, as I said, every atom contains 3 fundamental particles basically. There are electrons, protons and neutrons, but except one atom, that is hydrogen. Hydrogen has only one proton inside its nucleus and 1 electron revolves around its nucleus, that is all. No proton. The only atom who does not have neutron is hydrogen. But hydrogen has 3 isotopes, H11, H12, H13. This is called protium, deuterium and tritium, that we will discuss later. Protium is called normal hydrogen, deuterium is called heavy hydrogen, tritium is called radioactive hydrogen. The case is different, and we discuss about normal hydrogen here, right. Next, it is denoted by the symbol Z. Atomic number is denoted by the symbol Z, and atomic number uniquely identifies each element and determines its placement on the periodic table. See, this is a very nice point. Atomic number is uniquely identifies each element. That means one particular element has its own atomic number. Atomic number 1 means that is none other than hydrogen. There is no other element with the same atomic number. Understood? And atomic number 2, only helium, no other element with that atomic number. That means atomic number is uniquely identifies each element, and it also determines its placement on the periodic table. For example, hydrogen has atomic number 1 indicating 1 proton in its nucleus. Carbon has atomic number 6 indicating it has 6 protons. Next comes to mass number. The mass number of an atom represents sum of its protons and neutrons. Clear? So what is mass number? Mass number, suppose if you consider an atom, so this is the nucleus, protons and neutrons. Electrons revolve around the nucleus, that we know. So the number of protons and neutrons, sum of the number of protons and neutrons is called mass number. Suppose if any atom has 2 protons and 2 neutrons in its nucleus, then its mass number is 4. If any atom has 3 protons and 3 neutrons, then its mass number is 6. That means mass number is nothing but sum of the protons and neutrons present in the nucleus of that particular atom. That is called mass number. It helps distinguish between different isotopes of an element. We will discuss about isotopes, isobars in the coming topic. So it distinguishes between different isotopes. which have the same number of protons but different number of neutrons. Isotopes differ in the number of neutrons, that we will discuss in the coming topic. For example, carbon has 3 isotopes. Carbon has 3 isotopes: carbon 12, carbon 13 and carbon 14. Okay. So, just for an instance I will explain that. Carbon has 3 isotopes: carbon 12, 612, 613 and carbon 614. So, here this 6 represents the number of protons, nothing but atomic number, and the 12, 13, 14 represents mass number of these elements, isotopes. Now, if you want to know number of neutrons of these isotopes, you have to subtract atomic number from mass number. See, first one, 12 minus 6, 12 minus 6. I'll write here 12 minus 6, 6. The first one is having 6 neutrons, number of neutrons, and the second one, 13 minus 6, it has 7 neutrons, and 14 minus 6, 8. That means all these have same atomic number 6, 6, 6, but they have different mass numbers 12, 13, 14, and the reason for this difference in mass number is the number of neutrons, right? So, isotopes differ in the number of neutrons. Next, for example, carbon has, okay, we discussed representation of an element. An element is represented by its chemical symbol, which is usually 1 or 2 letters derived from its name. These symbols are listed on the periodic table. Okay, chemical symbol is typically accompanied by element's atomic number, subscript, and a mass number, superscript, to indicate its specific isotope. Just I have shown you the isotopes of carbon. Okay, no need to discuss once again. So, this is isotope of carbon, carbon 612, and this is carbon 613, and this one is carbon 614. So, this is the way of representing an element. Okay. So, the subscript represents, the subscript means this bottom side, down side represents atomic number. What is atomic number? Atomic number is nothing but number of protons, and the superscript means top. This number represents mass number. What is mass number? Mass number is nothing but number of protons and neutrons. That's all, very simple. These are all the most fundamental things, and actually most of you might have studied in class 8 or class 9. Okay. Next one, the most important one, and give a list of 30 elements of their 30 elements with their atomic numbers, and how this can be learned very easily. Explain with the simplest technique with world's best mnemonic. So, here I have asked ChatGPT to give a list of 30 elements, first 30 elements and their atomic numbers, and how can we remember these 30 elements in a easiest way, and explain with world's best mnemonic. Mnemonic are the techniques, memory techniques, which are much helpful for us to learn anything. Particularly those who are preparing for competitive exams, they need to remember a lot more information, and so mnemonic plays a very important role, and we can easily remember the difficult things in a less time. So, here in this list you can find the first 30 elements and with their atomic numbers: hydrogen, helium, lithium, beryllium, boron, carbon, and so on up to atomic number 30, zinc. And here, to remember this sequence, one mnemonic is mentioned in this mentioned by ChatGPT, but this is not complete. This is up to atomic number 10, neon, but further you can create your own mnemonic. This gives us just an idea how to create a mnemonic. See here, it's an interesting one. I'll see Harry, the happy helium balloon. Here Harry, first letter H, hydrogen, happy, helium, helium, second letter helium, lithium, floats over a lithium mine where he meets a bear. Bear means beryllium, and riding on a boron skateboard. Okay, so here these words, the first letter of these words represents the letter. Lithium, bear for beryllium, boron skateboard means boron, like this. And they crash into carbon tree, so carbon, atomic number 6, and disturbing a nitrogen nest, very interesting. So nitrogen 7, the angry birds throw oxygen X, X are in the shape of oxygen symbol is O, no? O in the like just like egg. So oxygen X on them, but they dodge them with a fluorine agility and escape into neon nightclub. Okay, this is one small story created here by ChatGPT as a unique story, and by remembering the story, and we can easily remember first 10 elements. Here you no need to follow this story, you can make more simpler story than this. Actually in a few months back in my 9th class I have created a story, but it was in Telugu, up to 30 elements. I made a YouTube video also, it is there in this same channel, how to remember first 30 elements in just less than 10 minutes or 5 minutes, 5 to 10 minutes you can easily learn the first 30 elements of periodic table very easily. Okay, so this gives a simple idea, that's all. Okay, I hope you have got some basic information from this video, and next will come next video will discuss few more important and fundamental topics, and slowly will move to the main topics of the chemistry.